All right, so this is the instructional video for section 5.4. Let me just move some stuff out the way here. And so for number 19, in this case, we're solving quadratic or higher degree inequalities. And so when you do this, you have to create intervals. And the way that you create the intervals is you find out when the function is equal to 0. So x, even though it's squared, right? If I square 0, it's going to be 0 anyway. So here, x is equal to 5. Let me write that a little bit better. Now the other one is the x plus 2 is equal to 0, which means that x is equal to negative 2. So when x is equal to 5, this inequality is going to be 0. The left side is going to be 0. And when it's equal to negative 2, is also going to be 0. And so what happens is we take these values here, right? These are the zeros. We take these values and we create intervals. Now we're going to go from negative 2. So we're going to go from negative infinity to negative 2. And then we're going to go from negative 2 to 5. And then we're going to go to 5 to positive infinity. So those are the three intervals that you're going to create. So if I have two zeros, then I'm going to have 3 intervals. And if I have 3 zeros, I'm going to have 4 intervals, and so on and so on. And so what I'm looking for is I am looking for the interval where the left side, is going to be positive because it has to be greater than 0. And so what I do is once I create the intervals, I choose a test point. And our test point is any value that's in the interval itself. So I'm going to pick negative 3 as my test point for this one. This one's going to be 0 because if I have a negative and a positive, 0 is in that interval. And then for this one, I'm going to pick 6. Now, you can pick any value you want, but I suggest don't go crazy. Now, if I plug in negative 3, and let's say, for example, I plug in negative 3 into the x minus 5 squared, x plus 2, and I get a negative value, then that's going to be negative for the entire interval. So I can pick negative 4, negative 5, negative 10, negative 1,000, negative 1,000,000. It's still going to be negative, if you will. And so I'm going to go back here and make sure, because I think I might have said this. So what I'm looking for here is the values that are going to make this negative. I don't know if I said positive or not. And the reason being is because it's less than 0. So I want to clarify that just in case. So then what I do is I'm going to create these little lines here just to kind of make it a little easier. So if I were to plug in negative 3 into the function, here I'm going to get negative 8 squared, and then here I'm going to get negative 1. And so negative 8 to the second power is going to be 64 times negative 1, which is negative 64. So for this particular interval, this is negative. Now, I'm really not concerned about the value itself. I'm more concerned about the sign of the value. So let's do the other one. If I plug in 0, right, I get 5 to the second power. This is going to be 2. So I get 25 times 2. And this one's going to be 50, so then this one's going to be positive. Now again, if I plug in 6, so it's going to be 6 minus 5 to the second power, 6 plus 2. So there's going to be 1 squared, and then this is going to be 8. And so that's just going to give me 8, which is positive. So now the original is x minus 5 to the second power times x plus 2 is less than 0. So I'm looking for the interval where I get a negative sign. And so the only interval where I get a negative sign is when is this interval right here, the negative 2 to negative infinity. So if I were to write this in set notation, I would say that x has to be less than negative 2. And if I write it in interval notation, I already have it there, so it's going to be that. So the solution is either one of these, depending on what they're asking you to write it as. All right, let's go to number 21, and we're going to do the same thing. We're going to find the values where this particular function is equal to 0. So what I'm going to do is I'm going to factor out an x squared. And when I do that, if I set each one of these equal to 0, I get that x is equal to 0, and then here I get x is equal to 4. So now that I have my two zeros, I'm going to create my three intervals. So I'm going to go from negative infinity to 0. I'm going to go 0 to 4. And I'm going to go 4 to infinity. And I pick a test point. So for this one, I'm just going to pick negative 1, which is probably the easiest one. This one I'm going to pick 1. And then for this one, I'm going to pick 5. Let me write that 5 a little better. And so I'm going to evaluate the function or the inequality at that particular value, right? So either one of those is okay. Now, since it's greater than 0, I'm looking for the intervals where I get a positive sign. So it's going to have to be a positive value. So if I pick this one, this is going to be negative 1 to the second power, negative 1 minus 4. So it's going to be 1 minus 5. So I get negative 5 for this particular one, which is negative. Now here, I'm going to pick 1. So it's going to be 1 squared, 1 minus 4. So that's going to be 1 times negative 3. And I'm going to get a negative 3, and that's going to be a negative, right? And then I'm going to go ahead and pick the 5. So it's going to be 5 squared. 5 minus 4, so that's 25 times 1, which is 25, which is going to be a positive value. So then the only interval where this inequality is positive are for values that are greater than 4. Now, 4 in particular is not a value. It's not a value that that is included in the solution. So when I write it in set notation, I am saying that x has to be greater than 4. So 4 is not part of the solution. So I can pick 4.1, 4.01, and that'd be okay because it's greater than 4. But 4 would not do it for me because if I plug in 4, I'm going to get a 0. And so if x was equal to 4, then I'm going to show you here real quick. So 4 minus 4 is greater than 0. So this is going to be 16 times 0, which is 0 is greater than 0, and this is false, right? So then 4 is not a part of the solution. So in interval notation, it's going to be the interval that I created, which is 4 to positive infinity. All right, let's look at number 25. So number 25, you notice that we have 3 terms. So x minus 1 is equal to 0, which means that x is equal to 1. X minus 2 is equal to 0, which means x is equal to 2. And x minus 3 is equal to 0, which means that x is equal to 3. So again, I have 3 zeros, which means I'm going to have 4 intervals. And so I'm going to have negative infinity to 1. I'm going to have 1 to, let me give myself a little bit more space here. I'm going to have 1 to 2. I'm going to have 2 to 3. And then I'm going to have 3 to positive infinity. So those are my intervals. Now I'm going to pick a test point. So that's going to be 0. Here, let's pick 1.5. Here we can pick 2.5. And then here we're going to pick 4. So when I plug in these values, right, I'm going to see if I have enough space to write these out. I probably won't do it for all of them, just for some. So I think you guys get the idea that I have to plug in that test point into my inequality. It's going to be 0 minus 1, 0 minus 2, 0 minus 3. So remember, we are looking for values that are less than or equal to 0. So therefore, anything that's, so this is a true statement, right? That's a true statement because 0 is less than or equal to 0. That's a true statement, right? If I get this, that's a false statement. That means that this is positive, right? And if I get this, negative 1 is less than or equal to 0, that is a true because then it's a negative value. So here I get negative 1, negative 2, negative 3. So negative 1 times negative 2 is going to be a positive 2. And 2 times negative 3 is going to be a negative 6. So this is negative. All right, so when I plug in 1.5, I get 0.375. Obviously, you can see that that's positive. When I plug in 2.5, I get negative 3.75. So you can see, obviously, that's negative. And when I plug in 4, I get a value of 6, which is obviously positive. So if I were to write it in interval in set notation, so the ones that are negative here in this particular problem is going to be this interval, right? Because that's a negative 6, and then this interval, which is a negative 3.75. So when I write this, that means that x is going to be less than or equal to 1, or x is going to be between 2 and 3. Now, when I write it in interval notation, might be a little bit easier. So I have to put the brackets because it's less than or equal to. So it's going to be that interval, right? And the next interval is going to be the 2 to 3. And so those are your two solutions for this particular problem. All right, let's look at number 29. So number 29 again, when you have one like this, the first thing that you have to do is you have to make sure that you have 0 on one of the sides. So it's going to be x to the 4th minus x squared is greater than 0. So I'm going to factor out an x squared, right? Sorry, let me get my pencil right here. It's going to be x squared minus 1 is greater than 0. So then, of course, this is going to be x squared, x minus 1, x plus 1 is greater than 0. So then x squared is equal to 0, which means x is equal to 0. X minus 1 is equal to 0, which means x is equal to 1. And x plus 1 is equal to 0, which means that x is equal to negative 1. So I'm going to create my intervals. I have 3 zeros. I'm going to have 4 intervals. So it's going to be negative infinity to negative 1. Yeah, let me write it here. That's okay. It's going to be negative 1 to 0. It's going to be 0 to 1. And then it's going to be 1 to positive infinity. So those are my 3 intervals. I'm going to pick a test point. And I'm going to pick negative 2. Negative 0.5. Sorry, let me rewrite that here real quick. So negative 0.5. This is going to be a positive 0.5. And then here, let me just pick 2. So instead of writing everything out, I'm just going to go ahead and plug in the value. So for this one, the value that I get is 12. Let me draw my lines here real quick. So just remember that you have to plug in the test point into the original and then see what you get. I would probably plug it into this one. So just remember that you're looking for values that are positive. So for the first interval, I get a value of 12, positive 12. So that's going to be positive. For this one, I get negative 0.1875. So obviously that's negative. For this one, I get negative 1, the same value, right? So that's going to be also negative. And then for this one here, I'm going to get 12. And obviously that's going to be positive. So since I'm looking for the values that are greater than 0, my two intervals that I have that will solve this inequality is this one and this interval. So now I have to write those. Interval notation is actually going to be a little easier. So it's going to be negative infinity, negative 1, union 1 to positive infinity. If I were to write it in set notation, then I would say that x is less than negative 1 or x is greater than 1. And so that's the solution for number 29. So the next one that I'm going to do is number 31. And as you can see, pretty much the process is the same every single time you're solving these. So I'm going to set this equal to 0, or I'm going to move the 1 over. So I get x to the 4th, minus 1. And so I can factor this. This is just the difference, right? So it's going to be x squared minus 1, x squared plus 1 is greater than 0. Since it's greater than 0, I'm looking for positive values, right? And within the interval. And so for here, I'm going to get x minus 1, x plus 1, and then x squared plus 1 is greater than 0. So, since x squared plus 1 has no real solution, right? So x squared plus 1 is equal to 0. x squared is equal to -1. Square root of x squared is equal to plus or minus the square root of -1, which means that x is equal to plus or minus I. And so therefore, this is not a real solution. I'm not going to use the x plus 1. So then my only zeros that I have is going to be x is equal to 1 and x is equal to -1. So it's makes it a little bit easier. So I'm going to go from -infinity to -1. I'm going to go -1 to 1. And then I'm going to go 1 to positive infinity, right? Sorry about my infinity symbol there. Got a little busted. Let me rewrite that. And so I'm going to pick a test point. So here I'm going to pick -2, I'm going to pick 0, and I'm going to pick 2, right? Those are the easiest ones to pick. So when I plug in -2, I get a value of 15. Let me do my line here so you guys can see it. And that's obviously positive. When I plug in 0, I get a value of -1, and that's obviously negative. Then when I plug in 2, I get a value of 15, and that's obviously positive. Since I'm looking for the values that are greater than 0, I'm looking for the positive ones. And so if I were to write it in set notation for my solution here, so O values x such that x is less than -1 or x is greater than 1. And so in interval notation, you pretty much have the answer. And so that's going to be the union of the interval -1 to -infinity, 1 to positive infinity, or to infinity. All right, number 33. So for number 33, what we're looking for is where is this undefined and where is it equal to 0? So where is it undefined? And the reason is because this is a rational expression, right? And so we have to avoid the values that will make it undefined. So when x is equal to 1, this particular expression or this particular inequality is going to be undefined, right? Because I cannot divide by 0. Now, where is it equal to 0? It's equal to 0 when my numerator is equal to 0, and that occurs at -1. So when you have a rational expression, you have to basically find out where is undefined and where is equal to 0. So denominator and then the numerator, right? And so now I can create my intervals, which will be fairly easy. So it's going to be -infinity to -1, -1 to 1, and 1 to positive infinity. I'm going to pick test points in each one of these intervals. And so just to show you what happens, so if I plug in -2, right? Let me create these things here since I've sort of cheated a little bit over there. So it's -1 over -3, which is 1/3, and that's obviously positive. If I plug in 0, I get 1 over -1, which is equal to -1, and that's obviously negative. If I choose 2, I get 3 over 1, which is 3, and that's obviously positive. So here, I am looking for the values that are positive. And so the two intervals that would make this positive would be x is, all numbers x such that x is less than -1 or x is greater than 1, right? And so in interval notation would be -infinity to -1, union 1 to positive infinity. And that's the solution for number 33. All right, number 43, the same thing that we did for the first one is we're going to have to set this to 0, right? So it's going to be x minus 2 minus 2 over 3x minus 9 is less than 0. Now, when we do this, we're going to have to just create one fraction. So we're going to have to put this together. And so I'm going to multiply, I'm going to write it in red here. I'm going to multiply this one by 3x minus 9 over 3x minus 9. And I'm going to multiply this by, x minus 2 over x minus 2. And when I do that, I'm going to end up with 3x minus 9. I'm going to write it this way. So 3x minus 9, x minus 2, minus 2, x minus 2, over 3x minus 9, x minus 2 is less than 0. Now I'm going to combine like terms. It's going to be 3x minus 9 minus 2, x minus 2. And then my denominator is just going to be 3x minus 9, x minus 2. Excuse me, it's less than 0. I might have to move 45 down a little bit when I get there. Actually, let me kind of get rid of it now, and I'll just rewrite it when I'm ready to do number 45. So here, I'm still going to combine like terms. So it's going to be 3x minus 9 minus 2x plus 4 over 3x minus 9, x minus 2 is less than 0. So I'm going to combine like terms. So 3x minus 2x is going to be x, and negative 9 minus 4 is going to be negative 5. Here I still have my denominator. And so what are my zeros here? So this is undefined. So if I say, okay, where is it undefined? It's undefined when 3x minus 9 is equal to 0. So 3x is equal to 9, x is equal to 3. This is undefined. So this is my denominator. And then the other one is x minus 2 is equal to 0, which means x is equal to 2. So these two are undefined, right? And then where is it equal to 0? And so it's equal to 0 when x minus 5 is equal to 0, which means x is equal to 5. So those are my three zeros. X is equal to 5, x is equal to 3, and x is equal to 2. Now I create my interval. So my first interval is going to be negative infinity to 2, 2 to 3, 3 to 5, and 5 to positive infinity. Remember, 3 zeros will give me 4 intervals. So test point here, I can go ahead and pick 3. Here, for this one, I can pick 2.5. Here, I can pick 4. And here, I can pick 6. So just to draw my separations here real quick, let me draw those a little bit better if I can. And so for the first one, when I plug in 3, I'm going to get a negative value. For this one, I'm going to get a positive value. When I plug in 4, I'm going to get a negative value. And when I plug in 6, I'm going to get a positive value. So the original one is I'm looking for the values that are less than 0. So I'm looking for the values that would make this negative. And so an interval notation is going to be 2 to negative infinity union 5 to positive infinity. Oops, sorry. Not positive infinity. 3 to 5. And so in set notations on numbers x such that x has to be less than 2 or x is between 3 and 5, right? 3 is less than x is less than 5. All right, so let's do number 45. This is the last one for this particular section. So it's going to be x squared, 3 plus x plus 4, x plus 5, and then x minus 1 is greater than or equal to 0. So the first thing is, where is it undefined? I'm going to just keep writing here so you guys can know that. So it's undefined when x plus 5 is equal to 0 or x is equal to 5. It's also undefined when x minus 1 is equal to 0, which means x is equal to 1. Where are the zeros? Zeros are when x squared is equal to 0, 3 plus x is equal to 0. Let me just write it here. And x plus 4 is equal to 0. So this is x is equal to 0. This one's x is equal to negative 3. And this one is when x is equal to negative 4. So you can see that I have 5 zeros. 5 zeros will give me will give me 6 intervals. And so the first one that I have, oh sorry, this is negative 5, not positive 5. Let me go back and negative 5. My apologies. So the first interval is negative infinity, and I'm going to write it this way. I think it'll be a little bit better, to negative 5. And then the next interval will be negative 5 to negative 4. The next one will be negative 4 to negative 3. Then it's going to be negative 3 to 0. It'll be 0 to 1. And then it's going to be 1 to infinity. So my test point here, interval, my test point, my result, and my sign. I'm just going to go ahead and put it that way. So I'm going to pick here negative 4.5. I'm going to pick here negative 3.5, negative 1.5, and then I'm going to pick 2. So the result here is going to be 216 over 7, which is positive. Here it's going to be 243 over 44, which is negative. For this one's going to be 49 over 108, which is positive. For this one's going to be negative 63 over 44, which is negative. Let me move this down just a little bit. So this is that one. And then this is that one, 0.5 and 2. So this one, oops, sorry. For this one, it's actually negative 0.75. For this one is the 63 over 44, which is negative, and then this is 120 over 7, which is positive. So I'm looking for the intervals where this particular inequality is going to be positive. Left side is going to be positive. So then what I have is I have this one, I have this one, and I have this one. Right? Those are the three intervals where this is positive. So if I were to write it in interval notation, it would be negative infinity to negative 5 with my bracket, right? I have to make sure I put that bracket. Union, negative 4 to negative 3, and then union, 0 and so for this one I'm just going to go ahead, so it's going to be 0. Oh, hold on a second, let me go back to this one. My apologies for that. And then union 1 to infinity. Now the reason the 0 is included is because when x is 0, and so my numerator, right, so that's going to be 0, that's going to be 3, that's going to be 4, and that's going to be equal to 0, right? And so therefore, that's why you have to include the 0 in the solution. And so in set notation, to kind of wrap up this, we know all numbers x such that x is less than negative 5, or negative 4 less than x less than negative 3, or x is equal to 0, or x is greater than 1. And so that's the end of 5.4. Thank you.